Okay, let's take a look at this question quickly. We are questions, I think it was question 5. This preparatory exam question 5. I think it was Gauteng paper. And we have the graph of h of x equals to a over x, where a is greater than 0, is sketched below. And we have point negative 1.5. This is the point. So Q is actually your y-intercept. Q will be our y-intercept. So the first question is saying write down the coordinates of Q. The coordinates of Q. So if we're going to look for the coordinates of Q, which is your y-intercept, what do we know about the y-intercept is that x is actually equals to 0. And then wherever we see x equals to 0, so we'll take h of x as a y to the power of x, then we put 0 on that side. So our y will be a to the power of 0, and our y will actually give us 1. So x is 0, y is 1. That's Q. That's our Q. So that's our 5.1. So if you want to add more, not always, because we find misconceptions that learners normally do every time when they see an exponential function and they're looking for your y-intercept, they'll always say is 0 and 1. It's not always in that manner. It is in that manner just because our asymptote this side is actually at y is equals to 0. Our asymptote is y is equals to 0. So if you to have a different function, maybe your function, let's say g of x, you had a function that is actually a to the power of x, then plus 2 or minus 2 or minus 3. So there's a value of q there. So it means like your asymptote will be actually at y equals to 2. And then it means our point will actually be at x will be equals to 0, and your y will actually be at 2 plus 1, which is 3. So it will all depend on where your graph is. The amplitude will not actually, not the amplitude, but the value of a, which is the base, basically it will be raised to the power of 0, so it will actually give us 1 in every sense. But if you have the value of q, then your y-intercept will actually be different. So don't always write the y-intercept and you assume that because it's an exponential function, it will actually be 0 and 1. No, it's 0 and 1 because your asymptote is actually at y is equals to 0. I hope you get that. And then we can quickly move to determining the value of a, which is 5.2. Let me just move it down a bit. Remember point P was actually 1 and 1 over 2, so we use that point. Then I'll also show you why I will not going to use this point for now, because it's also the point on h of x. So we had y equals to a to the power of x. So wherever I see x, I'll put 1 over 1, and wherever I see this is my x value, this is my y value, so wherever I see y, I'll put 1 over 2. So I have a 1 over 2 equals to a, then to the power of 1, then this will be to the power of 1. Is to the power of 1 and negative 1. Let's just also verify that the question was actually negative 1. So this was negative 1. My bad. That's negative 1 and negative 1. So the point is actually negative 1. Good. So we can easily find the value of a by saying 2 to the power of negative 1 is equal to a to the power of negative 1, where because the powers are the same, it means the base are also equal to each other. And somebody can also simplify it using the laws of exponents to say if I have 1 over 2 equals to a to the power of negative 1, I can simply say 1 over 2 can actually be written as 1 over a. 1 is equals to 1, it means a must be equals to 2. So all in all, both of them are giving us the value of a being equals to 2. We'll move on to 5.3. Alright, and let's take a look at 5.3, where we're looking for the inverse. I don't know if it's visible. Here's the question. We're looking for, write down the equation of the inverse in the form of y equals to so on and forth. So in talking about the inverse, we're talking about a reflection across the y is equals to x. So if we were to draw a line of the sort in the diagram, so it will actually be something along this line. And let me just find the ruler to put it at 45 degrees and then move on. Let me just take this ruler at 45 degrees. So if we're to draw a reflection, that means that line y is equals to x will be a line, I think. Let me just try to put the ruler here so that I can make an accurate drawing. It will be that line. It will just be that line. So this is your y is equals to x. So you're reflecting across that. So this is the graph that we're trying to. This is the equation of whatever function that we're going to reflect across this line. So that equation, you find that equation will, in actual sense, will be we have h, the inverse, and then let me just use the black pen, and remember your h of x was y is equals to 2 to the power of x. Remember we found the value of a as 2. So we're going to change positions. So wherever you see x, will see y. Wherever you see y, you see x. So they are changing position, they are swapping. That's you reflecting across the y is equals to x. That's what we actually learned in grade 9. And then we have to make y the subject of the formula. So we'll use the logarithms. This will be log. The base is still 2. And then x. So this is in exponential format. So in exponential format, if the base was 2, it will remain the base in the log, and what was raised will now be the subject of the formula. The exponent will just be the formula, and whatever was the subject of the formula will then be part of the log. So even if we can have an example to say we have 4 equals to 2 to the power of 2, this has been placed in an exponential format. We can actually write it in a logarithm format to say, oh, this was the exponent. It will now be the subject of the formula, which will be 2, and the base will remain the log, the base of the log, and then whatever was the subject of the formula will now be part of the log. So in true sense, this is actually 2. If you press this in a calculator, it will still give you 2. Then you can also use the loss of logs to actually simplify the right hand side. And then the next question says, let us write down, let us sketch the graph of h of 1 in your answer book. Clearly show all the intercepts with the x's. So I will try to use the same diagram so that it can actually be clear to us. Let me move up a bit. So normally what we do for you to see it, let me just erase this so that I can have some nice space. Just some nice space. Okay, good. Redraw the line to be a straight line, so that's accurate now, is that you look at the graph. If you remember, everything is swapping, so whatever was x will now be y, whatever was y is actually going to be x. So our asymptote was actually x, y is equal to 0. This was our current asymptote. This was our current asymptote. So it means the axis was the current asymptote. It means now if we are looking for the inverse, it means the y now will be the new asymptote. So this will be our new asymptote. Let me just also highlight it in purple. This will be our new asymptote. So our graph was very close to the negative side of x, the negative side of x. So it means our graph needs to be very close to the negative side of y. Let me go back. Let me just erase this. I don't know what happened there. Alright, so I'll try to draw my graph in black so you can see it. So it's going to be close and it will cross. Probably will have something along those lines. Let me just try to be very accurate because it doesn't make sense that let me say I'll have a graph of this nature. Since all this one will actually go up. This is as accurate as I could be. Then this will be our y is equal to the log 2. Remember, we also found that equation. So in actual sense, just to for learners to actually see it easier, is to say, all right, if my x-axis was my asymptote, it means that my y-axis will be my asymptote. And also look at the shape of the graph. You can see the graph is actually increasing. Even the graph will still remain increasing, still increasing. The graph was very close to the negative side of the x-axis. It will now be very close to the negative side of the y-axis. It will be very far apart, moving away from the positive side of the x-axis. It will now be moving away to the y-axis. The positive side of the y-axis. So it just becomes very easy to get the shapes correct. So when you look at the intercept, is they looking for the intercept. Remember, there's we said x was 0 and y was 1. So it means this side things will swap. This will be 1 and y will actually be 0. The same applies if you look for the reflection of this point, the reflection of point P. The image will actually swap. So x will be half and y will be -1. So if we were to plot P, you see x is half. So x is half. This is actually 1. So it will be half here. So it will be almost here. Say somewhere here. Yes, this is for the image of P, which is at half and -1. I hope that makes sense.